Okay, so reverse distribute, and I'm going to answer your question in a moment. So let me just remind what that question was. She said, well, is that all you do, or do you solve it? And that's a great point, because we get confused sometimes. What are we doing, right? Factoring is just kind of, can I reverse distribute something? Solving is solving an equation. And we have a few examples here. See how it's like equals 0? I want to know the value of k that makes this true. I want to know the value of x that makes this true. When I'm up here, it's an expression. I'm rewriting an expression. I'm not solving anything. There's nothing to solve. It's not an equation. So we factor so we can solve. So first we're going to practice how to factor, and then we're going to use that factoring to solve some of these equations. Does that make sense? It is confusing, and I know that was something that a lot of people had trouble with last year. I think you'll find this year easier. It takes that little just think time. So let's look at this one. You look at 9, you look at 9. I like to look at the numbers first. What's the greatest common factor of 9 and 9? 9. Then you look at each one of these variables. U to the 4th and u squared. What's the greatest common factor? V squared. V squared and v. What's the greatest common factor? V. Now we reverse distribute by dividing by your greatest common factor. So the 9's cancel out. U4 over u squared. So 4 factors of u over 2 factors of u. Picture kind of canceling out 2 of them. What's left? U squared. U squared. And remember, we had that rule. And remember our laws of exponents. If it's the same base and you're dividing, you subtract those exponents. But the reason we do that is you can picture 4u's over 2u's and canceling them out. Let's see, v squared over v. 2 factors of v over 1 factor of v. Okay, plus 9 over 9 is 1. U squared over u squared v. That looks like a plus 1 as well. And how do you check that you've done this correctly? Distribute back. No, that's 9. Remember how you multiply with the same base? You add the exponents. Am I getting the same thing back? Yes. The other thing you also want to do is check it here. Sometimes you don't find the greatest common factor. If it's still factorable in here, there's another greatest common factor, then maybe you didn't find the biggest one there. So question what I call type 1, factoring as greatest common factor.
I have a question.
Yeah.
For the things at the bottom where you solve the equations, I don't think you use either of those methods. I'll use the quadratic formula.
Okay, you hold that thought because that's an excellent thought. I do want to talk about that. I'm afraid I'm going to forget. When I get to solving, you'll remind me.
Okay, can we ever do any of these on our own?
Well, if you know how to do this and you want to go ahead and do them, you can. So I'm just going a little slower with people who might have forgotten how to do it, but you can work on your own if you like. Okay, now what I call type 2 is we're recognizing a pattern called the difference of squares. Difference means subtracting, right? So I'm looking for something that looks like a squared minus b squared. Something squared minus something squared. If you have that, it always factors to the thing that you were squaring plus and minus. So a plus b, a minus b. That's what, yeah? Is it ringing a bell? Is it coming back to us? Kind of. Okay, I'll take that. Okay. So basically the first step is recognizing the pattern. Is this something squared minus something squared? So there's minus, yes. 16, I think we hopefully remember that's a perfect square. And then is 9x squared a perfect square? Well, think about that. Is 9 a perfect square? Is x squared a perfect square? Yep, then that's a perfect square. This is a perfect square minus a perfect square. So think about this pattern. It says, well, take the square root of this thing. Take the square root of that thing. So I know it's going to be a plus minus pattern. What's the square root of 9x squared? 3x, right? You take the square root of both those things. And what's the square root of 16? So 3x plus 4, 3x minus 4. You can say 3x minus 4, 3x plus 4. Either way, right? Commutative property of multiplication. Now it's coming back. Awesome. All right, let's look at this one. Is this a perfect square minus a perfect square? Is that a perfect square? Is that a perfect? Yes. So you're saying, okay, I got it. Well, what is the square root of 36a squared? Don't look at me. Amy, what is that? Okay. Right? And then what about 64b squared? 8 what? 8b. 6a plus b, 6a minus 8b. Sorry, I looked it up too. Or 6a minus 8b, 6a plus 8b. And again, how do you check it? Multiply that. 36, okay, before you do any factoring, type 1 comes first. Is there a greatest common factor? Yes, what's the greatest common factor? 4. Thank you. So I'm going to factor that. So that becomes 9a squared minus, let's see, 16 b squared. And then now, you look in here, is this factorable? Yeah, that's a perfect square minus a perfect square. So that becomes 3a plus 8b. I'm sorry, 4. And 3a minus 4b. And you're right, she checked here, she said, wait, you take that out. So if you get to this point and you notice that, there's a common factor of 2 there, right? And that becomes 3a plus, but there's a factor of 2 here too. And that becomes 3a minus 4b, and 2 times 2, that's 4. Not 3a squared. 3a, because if you're taking the square root of a squared, you get a. So yes, thank you for, I did it wrong, I forgot. But we see it here. So sometimes they don't actually work until you factor out that greatest common factor. This is always the first thing. Do first, always. Always do first? Okay. Oh, now I'm looking for it. I won't forget it again. Okay, type 3. All right, what I call type 3 is when you have something of the pattern x squared plus bx plus c, where b and c are numbers, right, real numbers. So your leading coefficient is a 1, and then you've got some number in front of the x, and just a plain ordinary constant there. So when you do these, we're going to do a reverse FOIL. What's FOIL? What's FOIL?
I know. You know what it is?
Well, if I have like two binomials, right? I know, I'm just going to explain it. A lot of you remember it. FOIL is, how do you multiply like this? This is, you distribute the A and you distribute the B, right? So FOIL is an acronym for firsts. So you do the first things, A times C. Outsides, that's the AD, right? Multiply those. Insides, and then the lasts. So we use that FOIL acronym. It only works if you're multiplying two binomials. This helps us remember what to do. So instead of multiplying, we're trying to break it back apart. So here's how that works. You look for two numbers that multiply to this one, it'll be your C number, and add to that one. And last year, if you had me, and other teachers may have done this as well, but maybe not everybody, is I like to put the C up here, and then I look at B, and you know what I'm talking about, C and D? I'm looking at this. So C is your number at the end, and B is kind of your number in the middle. And then you say, gee, I need two numbers. They multiply to 8, but they add to -9. And you have to think about it. What is it? -8 and -1. Explain how you got that, because some people are a little stumped with that. No. I can't even think of like maybe breaking down. His brain just went there. Can you break that down? Like, how do you do that? No. I know. How do you break it down?
Because -8 plus -1, -8 plus -1, they both x each other out and create a positive, which is 8. But when you multiply them, -8 plus -1 is basically -8 minus 1, which
right.
is -9.
So these are the numbers that work. It's just what's the process that your brain is actually doing, you don't even realize it's doing it. And I'll help you out here. What you do is you say, what are the factors of 8? How do I get to 8? What do I multiply to get to 8? Those are the only two numbers I can think of. Now this is negative, and this is positive. The only way that can happen, if you're multiplying and adding, is they both have to be negative. Okay? Now add them. Which ones add up to -9? Well, this is the only one that works. So if you're looking for a process, you're having trouble with seeing what two numbers multiply to the top that add to the bottom, I like to start with just what are the factors of this top number, and then kind of work from there. Test them and see if you can get an add to that number. And then what do you do with those? Basically, you're going to break these up into two binomials. B squared, the only way you can get there is B times B. Remember, I'm reverse FOILing. And then these two things are what go here. And then what you do is you check it. So let's do a FOIL. B times B is B squared. B times -1 is -B. And that's -8B. So I'm starting to do the outsides and the insides, sort of in my head. negative b minus 8b, that's a minus 9b. Negative 8 times negative 1 plus 8. Did I get back to where I started? Yes. Okay? Yeah.
What about the way where you would place like the 9b with like negative 1b and negative 8, and then you would put them?
Yeah, I'm going to use that for this one.
Okay.
I find if you can remember that this is just a 1 in front, this one might be easier. But you're free to use whichever way you like. I think this one might be slightly easier if you can do that. But if you like the other way, you can absolutely do it that way. Now let's look at this one. This doesn't look like it fits the pattern because there's a 4 in front, right? You need a leading coefficient of 1 until I remember what. What do I need to do first there, Amanda?
Factor out the greatest common factor.
Factor out, always look, is there a greatest common factor? And there's a greatest common factor of 4. So you're going to divide all these by 4. So I'm left with a k squared plus a 3k minus 40. Okay? So the 4 is just going to hang out, and I know that this is going to turn into my reverse FOIL. I put my k, because now I've got that leading coefficient of 1. I'm just going to factor this. So the idea here is, can I find two numbers that multiply to negative 40, but add to 3? No. Now, part of the thinking here, this is the multiply to and it's negative, right? So that must mean that one's a negative and one's a positive. It's the only way you can multiply to a negative. So think about when you add these numbers, they're different signs. It's kind of a logical subtraction. So you're looking at 4 factors of 40 that are going to subtract to 3. You got them? What is it? Negative 5 and 8. Now, how do you know who's negative and who's positive? First of all, what he did in his head very quickly, because he's so smart, is he thought about what are all the different factors of 40. And if you subtract, do you get to 3? And this was the only one that worked if you subtract. And then you have to decide who's positive and who's negative. Notice how this number is positive. That means the bigger number had to be the positive number. If this had been negative, then the bigger number would be negative. That's what you did in your head, right, Joseph? Of course, it went instantaneously, didn't it? Which is good. And with time, everybody's going to be kind of instantaneous. You get better at it as you do it. And then I always check it. That's k squared plus 8k minus 5k. That's positive 3k. Negative 5 times 8 is negative 40. I still, to this day, I do a quick check. It's very easy to mess up these signs. Very easy. Anybody ever done that before? Mess up the sign? Just me? Oh, okay. I do it sometimes. Okay, so type 1, 2, and 3, we'll get you through a lot of them. Type 4 is a really cool one. For our purposes, we only use type 4 to help us with type 5. But type 4 has 4 terms. 4 terms in your polynomial. So you put them in degree order, which is degree. What's that? What's the degree? The exponent of what? The exponent of the variable. The degree of a polynomial is what?
How many different, the 4 of the x cubed.
So what's the degree of this?
X cubed.
Well, it's a number, it's 3. This is a degree of 3. And so what you do is you say, how many variables do I have here? I've got 3 of them, right? X times X times X. How many variables here? 2. How many variables here? 1. How many variables here? 0. So this number has a degree of 0. This term has a degree of 1. This term has a degree of 2. And this term has a degree of 3. The degree of the polynomial is the biggest of those numbers. So this is degree 3. It's a third degree polynomial. You put it in degree order from biggest to smallest, means biggest exponent to smallest. So you need to do that for grouping. And then I remember this as group, group, factor, factor. So you're going to group, then you're going to factor each of these separately. So you'll look at this guy and you say, geez, is there a greatest common factor here? Yes. Yes, there is a greatest common factor. Now, in the numbers, no. What about with the variables? What's the greatest common factor? X squared. Divide these by x squared. What's left? 3x plus 5, right? Yeah? Yep. Okay. Then I'm going to factor this one. Is there a greatest common factor? Yeah, what is it? 3. So divide these by 3, 3x plus 5. If all goes well, these match. Yay! Yay! Hey, do your happy dance. You go, woohoo! Now I'm going to factor again. The greatest common factor, but this time my factor is another polynomial. So I'm going to factor out that 3x plus 5. Reverse distribute, right? So when I divide this term by 3x plus 5, what's left? The x squared. And when I divide that term by 3x plus 5, what's left? And you got that? Not crazy about either. Again, you can multiply back if you want to see if you've done it right. Did we catch that? Yeah. Let's do another one. Do another one of these guys. Let's see. And again, I always check, do I have the greatest common factor? I do that first. I don't see anything. So I'm going to do a group, factor, factor. That's all you have to remember. Get it, the whole thing. Before, I'm just looking, can I do something out of the whole thing? Group, factor, factor. Write that down if you want something like that. So let's see. Now be careful when there's a minus. So I'm doing my group, and I am going to group it with the minus inside, but this is not a multiply. I always put my plus back in. I've just kind of, grouped the two pieces, but it's still being added to each other. So I put my plus back in. Okay, group. Factor, factor. So what's the greatest common factor of 5r cubed plus 30r? That's what I was doing. What is it? 5 and 30, 5. Greatest common factor of r cubed and r squared. Where'd y'all go? Good. Where'd everybody go? Okay, yes? Okay, and then when I divide by 5r squared, what's going to be left in the added? Okay, and then we have to do the same thing over here. Now, if they're negatives, factor out the negative, and then look at the 4 and the 24. That's 4, right? Okay, be careful now, because you're dividing by negative 4. So this becomes a positive r, right? Because you're dividing by negative 4. Dividing by negative 4 here makes that a plus 6. Yes? And multiply back just to make sure, because it's tricky when there's a negative that you take out. So you deal with that sign. If all goes well, you can do your happy dance. Because look, you have an r plus 6 that we can factor out again. And then we say, great, I factor out the r plus 6. What's left? 5r squared minus 4. And you do look, can you factor this again? For our purposes, this is, you could almost say it's the difference of squares. I'm only looking for perfect squares. So it's okay if you don't want to factor this further. If this had been like a 16r squared minus 4, I would have factored it again. So you always look to see, can I keep factoring? So you factor till you can't factor anymore. Question on type 4. Coming back to you. Anybody? Okay. So now we're going to use type 4 to help us with type 5. Type 5 is kind of like that type 3. Remember what type 3 was? X squared plus bx plus c. The difference is it's ax squared plus bx plus c, where this a isn't a 1. I don't have a leading coefficient of 1 anymore. So I'm looking at this example. 2x squared plus 25 plus 50. There are two ways to approach this. You can do this just like you did with type 3. Reverse FOIL and say, gee, 2x squared, how did I get there? Well, 2x and x, right? Isn't that the only way I'm going to get to my 2x squared? And then it becomes a little harder. You have to kind of really be good at your mental gymnastics and arithmetic. So let's see, 50. Well, was it 1 and 50? Does that work? Will that get me 25? If I put a 1 here, 50 here? No. I put a 50 here and a 1 here? No. All right, let's try 25 and 2. Does that help us? Well, if I put the 25 here and the 2 here. No. What if I put the 2 here and the 25 here? Does that work? I don't think that works. It's like you have to kind of do that FOIL again. So you're saying put the 25 here, the 2 here, the 25? Because that gives you 50 plus 2. That would give you 52x in the middle. So I'm just like reverse distributing like crazy, but I'm doing it in my head. I know a lot of people don't like this, especially when there's a lot of factors. This is easy if this was like a prime number. I did this, I looked at 5 and 10. And I said, 5 and 10. And I tried it both ways. If I put the 5 here, and I put the 10 here, does that work? I get a 20x plus a 5x. It does work. And it was all just doing that mental. This is kind of hard. You have to be real good with the multiplication, real good with what are the factors of a number. There is a way that it's more, it's a little more work, but you don't have to it's a process and we'll get you there. So question. Oh, okay, I got a question. So the way that you can do this that's more of a process is you have to kind of do a little converting here. I'm going to take this 25x and try and split it into two pieces. Well, how am I going to do that? The process is you take this 50 and you multiply by the 2. So the A times the C. 2 times 50 is 100. I'm going to make one of these guys again. Put that on top. And then this middle number, just like when we did up here, that goes here to the B. Multiply A times C, put it up here. Take the B, put it down there. And we're going to do the same kind of thing that we did up here. Two numbers that multiply to 100, but add it's going to have to be positives. Yeah?
Times 5.
What is it?
20 and 5.
Huh?
20 and 5.
20 and 5? Let's just test it. 20 times 5 is 100. 20 plus 5. Okay. Now what do you do with that? I'm going to just take this out here. So I've got 2x squared plus 25x plus 50. So you're going to split this guy up. So 2x squared stays the same. Instead of 25x, I'm going to write 20x plus 5x. Because 20x plus 5x, 25x, plus the 50. Right? Yeah. And then, how many do I have? 1, 2, 3, 4. I got 4 terms. Let's do type 4. Grouping. Group. Group. And then we're going to factor. So 2x squared plus 20x. Greatest common factor in there. And?
No, 2 and 1.
I'm going to x squared and x. So once you do the numbers, fantastic. Then you look at the variables. X squared and x. Greatest common factor. You know what the question? X. And then you divide 2x squared by 2x. What's that? 2x. 20x over 2x, that's 10, right? Now I'm going to do this one. 5x and 50 has the greatest common factor of 5. Divide those things by 5 to get an x plus 10. Yay! Right? X plus 10 is the same. I can factor that out. Once these are factored out, what's left? 2x plus 5. Does that match what I did with my little guessing check? You can, it doesn't matter the order of those units. So that's kind of that other process. It works. It's a little less guesswork. It's just, a little more computation. Do we remember that? Who remembers that? Anybody? Few people? Awesome. Few people don't? Here it is. You don't remember it. So we're going to repeat that with this guy. So you could try and do this guessing check. Let's just use this method though. So remember what you do? You multiply the 8 times the c. 4 times negative 5. That's negative 20, right? And then this number, this coefficient, which is just a 1. Okay. This is negative, this is positive, right? So these are going to be opposite signs. So two numbers that multiply to 20 but subtract to 1. Think of the factors of 20. Is it 1 and 20? Is it 2 and 10? Is it 4 and 5? Which is it? 5 and negative 4. Well, don't you think so? 5. Now, again, think about who's positive and who's negative, and you keep that in his head. But since this is a positive number, your bigger number will be positive. So what am I doing with that now? I'm going to be breaking up the middle term. So this becomes 4x squared plus 5x minus 4x plus, what's this one? Minus 5. What we're doing, right? Now I'm going to group. Now there's a negative here. I'm putting my plus back in because I am adding these things. The greatest common factor of 4x squared plus 5x. Greatest common factor of 4x squared plus 5x is what? X. Right, the number is just 1, so we don't use it. X squared and x. Divide an x, you get 4x plus 5. These are both negatives. Take out that negative. What's going to be left? Well, these will turn positive. Yay! Working. So now this 4x plus 5 is a common factor. And what's left? X minus, well, what's the coefficient here? 1. hard to read. 4x plus 5 and x minus 1. Well, remember this from last year? Yes. 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 And one word. Anybody at all say, oh, okay, yeah, sort of. I remember you. Yes.
I remember
Yes.
that.
Okay, good. All right, now, getting back to what your question was, Abigail, this is, why are we going through this thing? Why? Oh, it's so that we can solve these kinds of equations. We can't use our regular methods because you can't get paid by itself, right? It's really hard to do. So the idea is get it in a factored form. This one's already in a factored form, and this is the equation I want to solve. When this equals 0. We're going to use multiplication property 0, which says if something equals 0 and you're multiplying, well, this number had to be 0, right? This factor had to be 0, or this factor had to be 0. That's how you get a 0 as your answer, as your product. So when does this factor equal 0? When does k minus 1 equal 0? Yeah. K equals 1. And when does k plus 2 equal 0? Yeah. And k is negative 2. So I can now solve that equation. It has two solutions. Yeah. Well, yeah, you can say just take the opposite, but I want you to think why you're doing that. Because if you know why you're doing it, you won't forget how to do it. You are making this little factor be 0, and sometimes, what if it's, not such a nice easy one to do in your head? So you know what you're doing. So let's try this one. So the first thing you have to do is, it's a quadratic, so we have to factor this to figure out what it is.
Hey, I have a burger. Who's you saying it's not the quadratic?
I'm going to get there. So let's look at this. First, what type is it? Is there a greatest common factor? That's our first question. No. Is it a difference of squared? A squared minus b squared? No. Is it type 3? X squared plus bx plus c? Yes. So that means I can do my little reverse distribution. Notice this equals 0? I'm solving an equation, so keep it there. So let's see, the k squared is k and k, only way I can get there. Now I need two numbers. Multiply to negative 35, that adds to negative 2. And if it helps to make this little guy here to help visualize what it could be. They're going to be opposite signs, right? Yeah? Negative 75, starts with this. Right? So he said these two things, when you multiply you get negative 35. When you add them, you get negative 2. If you're not that quick, that's okay. Just think of all the factors. 1 and 35. No, 3 doesn't work. 4, 5 is that right? And until you find one that works. And test it. Multiply and add. So that's minus 7 and that's plus 5. I can do a quick FOIL. That's fine, minus. Okay, yep. And just check that you did it right. What are the solutions going to be? A equals 7, K equals negative 5. K minus 7 is, if you plug the 7 in, 7 minus 7 is 0, or negative 5 plus 5 is 0. We've solved it. As Amanda points out, there is something called the quadratic formula. It's another way to solve equations that look like ax squared plus bx plus c equals 0. If you have an equation like this, x will equal negative b plus or minus the square root of b squared minus 4ac over 2a. You have to identify a, you have to identify b, you have to identify c, you have to do all this substitution. When it's easy to factor, I think the factoring method is a better one to use, when it's easy to factor. When you get to ones that maybe you're having a little more trouble with factoring, maybe go to this. Or some of them can't be factored, right? They can't be factored, so you use this as well. So keep that one in mind if you're really having trouble when you're trying to solve this equation. So thank you for reminding me about that. Okay, what do I do for number 13? What do I do there? Joseph? Yeah, so remember, we always want 0 on one side, so let's add the 6 over. So now we're solving x squared minus 14x plus 49 equals 0. Because our whole thing is based on we want factored form to equal 0. So let's look at this. It looks like a type 3. Right? X times x, that's how you get x squared. Two numbers that multiply to positive 49, but add to negative 14. Yeah. Negative 7 and negative 7. This is actually another pattern if you recognize it. It's a little bit harder to see. It's like when you have an a plus b squared. It's okay, just do this. So it's x minus 7 squared, x minus 7 squared equals 0. So what's x? 7. This one only has one real solution. So that's it. Notice how I said one real solution. When you get to algebra 2, you'll learn about the other solution. That maybe aren't real. That's okay, you don't have to worry about that now. Don't worry about it now. The idea being, you look at the degree, that's how many solutions there are. They may not all be real. Okay, so anyway, now we're back to this 14 here. So 3x squared minus 14x plus 16. Oh boy. So this is not type 1. I don't see any common factor. I was hoping 3 would work, but it doesn't. It's not a difference of squares. It's not a type 3 because this is not a 1. It's got 3, not 4 terms. It's not type 4 or type 5. So this is the one where you can try it against a check, or we can kind of use that more methodical method. So let's just review that one more time. So you say, I want to break up this middle term. So I do a times 3. What's 3 times 16? Ooh, yeah? 48. So I'll just put a little work over here. Has to add up to negative 14, the b. That turns out on top, this one on the bottom. Two numbers that multiply 48 but add to the negative 14. Both have to be negative, right? Right? You figured it out? Perfect. Okay, multiply up, add down. Perfect. So the 3x squared stays. It's going to be minus 8x minus 6x plus 16 equals 0. Don't forget to equal 0. You are now solving an equation. You're not factoring for factoring's sake here. You want to find a solution. We're going to group. I'll put my plus back in. And then factor. 3x squared minus 8x. What's the base point of factor here? What's the next, isn't it? I get a 3x minus 8. What's going on here? Definitely want to take out the negative. 6x and 16. What's the greatest common factor there? 2. Goes into both of those. So let's see, I'm dividing by negative 2. So it looks like a 3x. And 16 over negative 2, that's a negative 8. Happy day. Yay! Look, they're the same. So now I can factor out an equal 0. 3x minus 8 times x minus 2 equals 0. Now this one's careful. I'm factored, so I want to find the solution. Now this one's 2, right? Got it. Okay, and then what's this one? Now some people can do this in their head, some people can't. If you can't, just say when does 3x minus 8 equal 0? Add the 8 and then divide by 3. So these are my two solutions. Okay, what do you think? Got thumbs up? We could do complete the square. I'll be up for that. We're going to need to know how to complete the square in this next little unit. Ready? You ready?
Wait, I have a question.
What? Yes.
Do you even want a fraction or that? Or
Yes.
do you want a decimal?
No, I want that. I'm giving the exact solution unless told otherwise. If I was doing a physics problem of some kind, I would probably maybe make it a decimal because I use another number. But give me exact unless told otherwise.
Okay.
So leave it a fraction. Okay, I'm going to need to erase this, so I just want to make sure you've got this copied down. Who's still writing? I'll just follow over here. Completing the square. Oh, yeah. So let's review that. I'm just going to erase this bit just so we can see what we're doing. Don't let me be done. But not too much. So this looks like it's nicely set up to do this. So by completing the square, though, I want the number to be on the other side. So I'm going to add the 32. So you do p squared plus 14p. Leave a little space here. Equals 32. I added the 32 to that side. So I want to make a nice perfect square, kind of like this one, where it's a binomial square times a binomial square. That's what I want here. A perfect square trinomial. The way you get there is you look at this plus 14 and you take half of it. What's half of 14? 7. Then you square that number. Yeah, what's 7 squared? 49. That's what goes here. Look at B. Half it, square it, add it. Half it, square it, add it. Now this is an equation, and I just added 49 to one side. What has to happen? I don't have my hand in here. What do I have to do, Ellie? I have to keep this equation in balance, add it to the other side. This is a perfect square trinomial. So it will be, you take the square root of p squared, you take that square root of 7. This is a plus situation. That becomes p plus 7 squared, and then I have to add 32 and 49. You know what you get?
I don't even know where you get all this from.
Where am I getting what from? It's a method to solve a quadratic, completing a square. Well, keep watching. You took this last year, yeah?
Yeah, but I forgot.
Well, so all we did was we're playing a little. Let me finish. We're doing some mathematical tricks here because I want something squared equals a number. So I made this something that's a perfect square so that it can have a number on this side. Because what am I going to do? I'm going to take the square root of both sides. And let me just revisit. If I said x squared equals 4, what is x? This is something completely different. Just another example. If x squared equals 4, what's x? And negative 2. So I've got something squared equals a number. So if I take the square of both sides, square root rather, I get p7, p plus 7 here. What's this? What is, if I had x squared equals 81, what do I have? Plus or minus 9 when you take that square root. So now I'm going to subtract 7 from both sides. So p equals negative 7 plus or minus 9. And let's see what those two numbers are. Negative 7 minus 9 is negative 16. And negative 7 plus 9 is 2. And those are the solutions.
I have a question.
Okay, what's your question?
Where did the 49 come from?
I completed the square on this. I added that to, all legal algebra, right? I added that to that side.
Yeah?
And then I did half and square is how you complete the square to find a perfect square
I don't
trinomial.
understand. How did you get a 49?
Half this number and square it. What's half of 14?
7.
Square it. And then if you add it to one side, add it to the other. And that gives me this nice perfect square here. Same thing on this side. Yes? Is the what? Well, you guys do it all the time. It's illegal algebra. I see it all the time. So anyway, so let's review the method. Put the 12 onto the other side. X squared plus 8x, leave a space, equals negative 12. Look at the 8. Half it, square it. So half of 8 is 4. Square it, 16. I put 16 on one side, put 16 on the other. Now I'm still in balance. Perfect square trinomial. What is that perfect square trinomial? That's x plus 4 squared, right? Square root of x squared, square root of 16. Use that plus sign. That's negative 12 plus 16, 4. Square root both sides, right? So that becomes x plus 4, and this becomes plus minus 2. Don't forget the minus. I'm going to subtract 4. So x is negative 4 plus or minus 2. What are those two numbers? Negative 4 minus 2 and negative 4 plus 2. Yes? You can. These are different methods. I want you to have a nice bag of tricks. So you can factor it if you can. Sometimes they're not factorable or they're very hard to factor. So if that's true, you could use the quadratic formula, or you can sometimes use completing the square. Completing the square works best when this is a nice even number here. Otherwise it starts getting a little hard. Yes?
How you got to x equals negative 4 plus minus 2?
I took the square root of both sides.
No, I did so there.
Oh,
but
yeah,
you don't
I
get how
subtracted
you got
4.
x equals negative 6.
Negative 4 minus 2 and negative 4 plus 2. Yeah. That's our factoring review, my friends.